Good morning. Today we're going to be talking about another type of transformation, and today we're discussing dilations. I usually refer to dilations as what they do to your pupils when they put the drops in them when you're going to have your eyes checked. In the case of geometry, a dilation can either be shrinking the figure or enlarging the figure. So, just in math terms, a dilation with the center of dilation at C and a scale factor n, where n is greater than 0, can be written as the dilation, that's the scale factor, and that's the center. So, a dilation is another one of our transformation with these properties. The image of C, which is going to be the center, is always itself. The center does not have to be in the center. The center could actually be a point on the corner. So it just depends on how your figure is drawn, and we'll look at that in our examples. For another point R, the image R is going to be on the original line from the center to your original preimage point R. And C R prime is equal to your scale factor times just your regular preimage points C and R. Or to get the scale factor, you would divide your center to your new R by center to your old R. Dilations preserve angle measure. So, is a dilation rigid motion? Does it preserve angle measure? Yes. Does it preserve distance? No. So a dilation is not going to be isometric, and it is not going to be rigid motion. So you have your original triangle PQR, and you have the center, which is way out here, and you have your change, which is P prime, Q prime, R prime. So all of these properties are diagrammed in this diagram. I think it's still a bit confusing, so it makes a little bit more sense when we start seeing the examples. So the scale factor n of a dilation is the ratio of the length of the image to the corresponding length in the pre-image. So any of these will give you the scale factor. So it's the center to your new R over the center to your R, or you can use your new length R prime P prime over your original RP, or your new length P prime Q prime over your original PQ, or your new Q prime R prime over your original QR. Now, take all this in and let's look at how an example is going to work. All right. A dilation is an enlargement if the scale factor n is greater than 1. Which makes sense. If you're going to enlarge it, you have to have a number more than 1 to make it bigger. A dilation is a reduction if the scale factor n is between 0 and 1, which means it's going to be a fraction. And that makes sense also. If you're going to shrink something, you have to take a portion of it. So let's look at this example. Here, the center is not actually in the center. It's here on the corner. So the A and the A prime are going to be the same. Now, using the notes that I told you about here on how to figure out what the scale factor is, we are going to say, all right, my C prime to D prime is 4. My C to D is 2. So 2 is going to be my scale factor. 2 is greater than 1, so it's an enlargement. Let's look at this example. Here, the center is actually kind of in the center. So C is going to be equal to C prime, but it's the center, so we're just going to leave it at C. Now we're going to say, okay, the original, which is going to be my E to H, that's going to be down on the bottom. My new, which is E prime to H prime, is 2. That's going to be on the numerator. and that's going to give me 1/4. That's a fraction, so this is going to be a reduction. Let's look at an example. Remember, this is scale factor, this is center, and I have got triangle XTR, and I'm going to go to the new triangle, which is X prime, T prime, R prime. And I want to know, is this change going to be an enlargement or a reduction? We'll look at it. The original is here, the small one. This is the new one. We know it's going to be an enlargement. We can see that, but we have to figure it out mathematically. So what is the scale factor n of the dilation? All right, so the new X prime, T prime, I've got 4 from here to here and 8 from here to here. So to get the total distance, I have to combine them, and it's going to be 12. So I'm going to get 12 over 4, which is 3. So it's going to be an enlargement with a scale factor of 3. Okay, if you have questions about that, just let me know. Let's look at the next example. The next example is going to be finding a dilation image. Okay, so we want to know, what are the coordinates of the vertices of dilation 2? So it's going to be what? An enlargement. And I've got triangle PZG, and then I'm going to have to graph the image of the pre-image PZG. So I'm actually going to be graphing P prime, Z prime, G prime. So let me draw PZG, and I put what the points are at each of those locations. Now, to do a dilation with enlargement factor of 2, I just have to multiply each of the points by 2. So I'm going to multiply 2 times 2, which is 4, 2 times -1, which is -2. Then at Z, I'm going to multiply 2 times -2, which is -4. 2 times 1 is 2. And then at G, I'm going to multiply 2 times 0, which is still 0, and 2 times -2, which is -4. Now I'm going to graph my new points, and that's going to give me the enlargement, the new triangle, which is going to be triangle P prime, Z prime, G prime. If you have any questions, you can send me a message on Remind, or you can contact your teacher on Google Classroom. Let us know if you have any questions about any of this new content. See you tomorrow.